Okay, so I'm back to connecting this new power cord, and after dealing with my kitties, and I've got an old cat. She's 14, I think, and that cat, it's a female cat, does not get along with young Draper, who you've met a few times in my shop now. Young Draper is a little rambunctious, and ooh, that didn't sound good. Yeah, the insulation just shattered in there. Young Draper likes to go after old Tabby, is her name. So unfortunately we have to keep them separated, which means one or the other has to be locked up in a room, or Tabby goes outside. We let her go outside. It's become kind of a difficult situation in here for our older cat. The poor thing spends its time alone in a room or outside. Outside's not so bad in the summer. The summer is leaving. The winter is arriving. And going outside's not so nice, especially for an older cat. So I don't know what to do. I just let her go outside because it's not terribly cold today. I don't know, it's about 6 or 7 degrees outside. That would be Celsius, by the way, for my American viewers. Hey, American viewers, I'm coming down to Florida in a little over a week. I'm going down to see my uncle in Florida with my mother. So it's been a while since I've traveled, quite a few years now. But you know, last time I traveled I went to India. So a little bit different than going to the States, that's for sure. Now this is going to be a messy connection here. Gonna have to kind of rely on so I'm making this one airborne also. I'm gonna have to rely on the solder to really make this thing a good connection. Just trying to get the cloth out of the way here. Down ye cloth, there we go. Okay, I think I can probably get a whack of solder on that. Great thing about solder is how the smoke manages to find your face all the time. That's gonna do it. Okay, that's not coming apart. Not coming apart. Yeah, I think I'd be smart to put some tape on that right now. Yes, I'm going to put tape in the back of a radio. Again, not the best thing. So be fined for 20 years. The question is, will I be fined for 20 years? But by year 40, this tape will be a problem. If this radio is still kicking around, that would be the year 2050. This radio would be 110 years old at that point. And I'd be about 100, I think, wouldn't I? What would I be? I don't know. The world is going to change a lot in the next 20 years, including the ability to have people live much, much longer lives. You can anticipate this coming. So my children, they're in their 20s now, will probably live, unless an unfortunate accident happens or something like that. But if they if they avoid the tragedies of life, they and everybody their age stands a chance of living to 150. And that's a reality none of us are really seriously thinking about. 150. Oh, did I just win something? What happened there? Well, that's the buzzer on my clothes dryer going off, if you can hear that, if you heard that. Once again, this is going to be another messy sort of connection here. It's messy because the stranded wire is coming apart. It's kind of fraying out, which is why you don't normally use a stranded wire around the back of a radio. It's a hassle. Stranded wire gives you flexibility. So if you need flexibility, like the power cord, you got to use stranded wire. But if you don't need flexibility, then you should be using single conductor wire. Okay, let's throw a little solder onto this. I can't quite see how that's going. Oh, I could have put shrink sleeves on there, for crying out loud. What a dummy. I'm a dummy. Solder's good. But it's my own radio, so I will continue being a dummy here. Shrink tubing would have been a much better choice on this, even if I put it over top of the tape. Even I could even do that, but not once the wires are connected. I'm too lazy to redo it. That would be called rework. Rework is a bad thing for efficiency. You really want to do things once. Yes, and do them right. Yes, I know. And I have not really done this the best way. Okay, when you're putting on this tape, I don't know how many people know this, but you're supposed to stretch it on the way on. Sometimes as much as almost 50%. So if you have a 10-inch piece of tape, you're supposed to stretch it out to 15 inches. I could do that in centimeters. If you have 10 centimeters, stretch it out to 15 centimeters. If you don't know what an inch is, not that it matters. And who doesn't know what an inch is, for crying out loud? Okay, that'll do for now. I can pull this back a little bit. Just like that. There we go. Another job done on this radio. Now we could do the power supply capacitors, because they're going to be down in this area anyway. In fact, there's only one capacitor. This is easy. I like easy. Let's do easy. So who do we want to put in there? We could put this big one in there. I mean, physically it's big, but it's the same. I mean, you've got lots of space for it. 450 volts, 50 microfarads, just about. Now, why did this guy have this connected to two ground points? Why didn't he take these two capacitors, simply parallel up the wires like they're one, and then connect it in 2 points? Why did he connect one over here, one over there? Is this something other than a ground point? This is one of the connection points. Did he do something stupid? Here's the other connection point. That's clearly the ground. This is not clearly to ground. What's he up to here? Pulse coming off of this wire. The dryer does call me. Let me deal with that. Okay, onward here. Let's install this filter capacitor. Oh yes, I was just pondering about what's going on here, that somebody connected this wire to two positive terminals, two 10 microfarad capacitors. One of those capacitors grounded. The other capacitor connected to here. What is this? Is that by some chance the bypass capacitor for... Yeah, you know, it could be. That could very well be. There's a big ugly resistor there. Yeah, it's not so big. Yeah, it could be one is the filter and the other is the bypass. 10 microfarad filter. That's small. That's very small. Especially if that's all this radio is relying on, is one filter cap. And that would appear to be the case. And we can connect this up. You know, the fact is, if it was originally two capacitors paralleled, well, that doesn't make sense what I just said, because he would have connected the negative end. Yeah, what I just said didn't make sense at all. In fact, that capacitor just doesn't make sense unless this is a ground point. What? And it's obvious somebody else did the work. It was not factory original. Did they do something dumb? Because I know I can do something dumb. Let's see if this is a ground point by checking. No, there's no way that's a ground point. What was that person doing? Why would they put a big fat capacitor there? Yeah, that's really that's a good question. So I can't imagine why. Why would that be there? Why? So let's look at the leads coming off of this point. Okay, so one lead is back to the transformer, and another lead is here. Where the heck's that going? It's going through a hole and heading up to the top of the radio, and this very similar wire is coming back and going to ground. What? What's going on? How's all this work? Where's my schematic? Okay, I'm gonna turn the radio over, which is easier said than done, because it weighs a ton. Okay, so hey, guess what? That wire's coming up, it's going to this coil. Okay. Now it make a little more sense. No, that doesn't make a little more sense. No, yes, there is another coil. There's another coil in there. Yeah, this is not a permanent magnet speaker. I mean, an old radio like this would not be very likely to have. What's going on? Oh, that's... It's not very likely to have a permanent magnet speaker because they couldn't make magnets strong enough to do the job back then. 1934. Okay, so let's make an assumption here. Let's assume that... Oh, I can't make an assumption here. what's going on? So there's a bunch of wires going up there. That one, that one, that one, that one, all go through a hole and head up to the top. Hey, I wonder if any of this has anything to do with this burned up resistor and this flying connection. Well, let's keep moving. Keep moving. So we'll put in the capacitor we know has to go in. I'm not going to put in a whopping 450. I'm sorry, a whopping 47 microfarad one in place of a 10. It's a big change. Let's think some more about this. Now, normally what you would find is two separate capacitors in the power supply, both of them grounded to the chassis or to a neutral point in the radio, and the positive leads going on either side of a high wattage resistor or an induction coil. Often that induction coil is the same coil that's providing the magnetic field for the speaker, and that's what's going on in this radio. So you'd want to have a capacitor connected to either side of that coil. Basically, that's what you're trying to do. So if we think of the coil as being up on the speaker, and these wires are coming back, these 4 wires here, 2 of them are related to this coil and the power supply. 2 of them are going to the output transformer, which is also mounted up on the speaker, and ultimately feeding the voice coil of the speaker. So now we ask ourselves, okay, so these 4 wires, 2 pairs, which ones are which? So my first observation here is that yeah, I'm kind of slowing down at this point, aren't I? Okay, so rectifier tube, this is probably the output tube right here. So this being the output tube, that should have some wires that go to the output transformer. Yeah, I got to turn this radio over again because I could see the color of the output transformer wires. As ugly as they were. Which way should I go? Let's go this way. I think I'm going around the same way over and over. Yeah. When do radios get damaged? During things like this. Okay, so here we are. Here's the this is the output transformer. These are the 2 leads coming to it. And they look pretty dark to me. Now, where are those other yellowy ones going? Oh, they're way down below. Okay, the yellowy ones are going to the speaker field coil. That's the proper term for it. And these darker ones are coming up to the output transformer and ultimately the voice coil. Let's put this back upside down again. Here we go. This gets more tricky every time I do it. Getting things a little bit wrapped up here. Get this out of here. Okay. So now we're saying these 2 wires, these are field coil wires. These 2 wires are output transformer wires. Okay, so these are the 2 field coil wires. One of them goes to ground. I'm having a lot of trouble getting my head around that. That's That's not right. I may have to go away and ponder the situation here a little bit more. We were going to put the big one in on this wire, weren't we? And we could continue doing that. So I will, while I sit here and ponder how badly I need the schematic for this radio. And I have not found it. This radio has a name. It's called the EARL. And I saw on the internet it was called the very rare EARL. That's got me a little bit excited. 1934. It's a pretty old radio. Let's solder that. That's definitely the ground side. That's a good thing. Because this side's going to be up at some high voltage, 250, 300, who knows. Put a little spaghetti on it. This stuff is the hardest stuff to store. And really, everything I've done with it, I'm keeping it in a bag right now. It's just crummy stuff to store. And this is going to be another flying connection, which I'm going to shrink tube this time. Yay! Way to go, Jimmy. Yeah, okay, so this somewhat ugly color of green will do. I feel a little better with a shrinked on insulation. Let's tuck it under that wire there. I don't want to bend too many things here. Too many old things anyway. Hey, come to think of it, even I'm having trouble bending. Well, that's a little tight. Now this is a short wire, you know, if I wrecked it I could easily change it. It's not that big a deal. But I don't plan on wrecking it. Oh, come on. If I don't get this slid up far enough, it's too much. It's too much. If I don't get it slid up far enough, when I heat up the wire to solder it, the shrink tubing will shrink wherever it is. I've had that happen a few times where I go to move the shrink tubing and onto the connection when I'm done and it's not going anywhere. Come on. What's holding it? There we go. This will be a little tricky because the wire is there's a sharp bend right at the connection point here. I got my fingers all over it. I know you can't see it. Okay, let's that with a little bit of solder. Get in and get out quick with this. I want to put too much heat up on that shrink tube. Okay, now I gotta bring this tube up, get it around this connection here, which is a little fat. Hey, tape sounds like a good idea now. What's going on there? I don't want to cut it, I'm just using my cutters like pliers. Not the smartest move either. Come on! I'm gonna break something at this rate. Break my will to continue. Here. It's easy to crush a rigid wire with a pair of pliers because, oh, this is not going well at all. This was a big mistake. I should have put a larger shrink tube on it. Oy, oy, oy. Look at this. What a mess. I'm trying to chintz out on the shrink tubing, and now look at this. I'm going to rip a hole in it soon. We're going to end up having to put tape on this anyway. This is dumb. Okay, that's totally unsatisfactory. Because this is a high voltage connection, we can't afford to have a little bit of it exposed here. Some guy 20, 30 years from now, hey, hopefully it's still me, poking around in here and get a shock. We'll have to redo it. That's the unfortunate situation here. Didn't I just give a little speech about rework? Rework is bad. Yeah, and I got these kind of twisted together too. Let's see if I can just poke them apart here. And I did. Good for me. Okay, another piece of shrink tubing. See, I'm trying to preserve it and I ended up wasting it. Put this bigger piece on. Let's put on a red piece. Red piece kind of hints at it being high voltage. At least this should go easily. Did I say something about easily? Let's try another camera angle here. Not sure my lead is long enough. No, it's not. See, the autofocus is picked on the thing that's in the foreground. You're gonna have to learn how to. Hey, there we go. Bingo. Now you can watch very closely as I make a mess of this connection here. In fact, you can see it better than I can. Okay. Don't roll over. Yes, okay. I think yes, okay. I can't keep my eye on the screen, obviously, to see what the camera's doing. Especially in terms of focus. Okay, I don't want to make a big lumpy connection here, because I do have to get the shrink plastic over it still. Okay. There we go. Now there's a little bit of solder on these wires, so this should be real easy to do. Whoosh, there we go. Now, there's a really sharp bend here. I gotta get the shrink plastic out. Ow, ow, ow. I better let it cool off. Okay. The shrink plastic's not the most flexible stuff either. Okay, it's going over. Way too much of it. About twice as long as I need it. You know what, I can bend this temporarily, get the plastic on it, and bend it where I want it afterwards. Get on there. Come on. What a mess. There we go. Got a sharp point right there. It's kind of digging into it right there. Another, this is a rotten job. This is just not gone at all the way I wanted it to. That's terrible. Arrgh. Gotta get rough with it. Gotta let him know who's boss here. Apparently it's not me. I don't know what's going on. Lucky thing about this is once you shrink it, all evidence of this nonsense will be gone. What a mess. Okay, everybody, this is not the way to do it. But sometimes it's good to see the not way. Okay, connection's up about here now. Isn't that nice? Let's shrink. Maybe tape has more hidden advantages than it's going to put a fair bit of heat all over the radio here, but what kind of result did we get from that? Don't be fooled. Well, there it is. That was terrible. Terrible floppy flippy thing here. I don't like it at all, but it's loose as can be. Well, not so good. Everything's all loose and shaky in there. Not really the way I want it. Now I gotta get back to this question. What is going on here? So we have a wire coming out of the transformer, or so it certainly appears. Connects to a wire which immediately heads for the coil. So I would expect one capacitor to go from ground to this point. Then it comes back from the field coil on this wire, which is then connected to ground in the stupidest way over here. That's it there. I don't know what to think of that. I really don't. So when you don't know what to do, you just carry on doing something else, I'd say. So we could go after this capacitor here. We could do the two on this side. They look pretty easy to do. What's going on down there? Look at the lead wire is pushed through a hole and is actually soldered on the other side way under this thing. Yeah, good luck on that. I can't even see where the lead wire is, so this is not an easy one to do. And this guy's kind of hidden under there. He's doing the same thing. He's going in the same spot. Probably a ground point, that would be my guess. Oh, there's a mica capacitor way down under there too. I generally don't worry much about mica capacitors. Well, we got a number of wiring weirdnesses going on. Okay, so we still have this thing going on. I need a schematic. I'm going to go hunt some more for a schematic, although I hunted pretty thoroughly already. I'm going to hunt some more because the EARL is giving me a headache at this rate. So I'm going to stop at this point and go do some thinking and some research. Thanks for watching.